So, now to move to the main business of the evening and to the Barlow Lecture 2015. For those of you who don't know Barlow, just a few words. Harold Barlow was head of Department of Electronic and Electrical Engineering at UCL from 1950 to 1967. In those days, it seemed that heads of departments had boundless energy. Next year, I shall have completed 10 years in the job, and when appointed for a further period of 5 years after my first term, I said I'm definitely not doing more than 10 years. But Harold was made of different stuff. He held the post for 17 years. He invented a whole range of microwave waveguiding structures, including the H01 mm waveguide. And this would have been the method of transmitting internet data around the world had not another of our graduates, Charles Cow, demonstrated the feasibility of optical fiber. Barlow is recognized for his many contributions to microwave research. He was awarded the IEEE Kelvin and J.J. Thomson premiums, the Faraday Medal, Ursi's Dellinger Gold Medal, and the IEEE Kelly Prize during his career. And he founded the lecture that bears his name. This evening, we're absolutely delighted to welcome Jeannine Sargent from Flextronics to give this year's Barlow Lecture. Now, I would be prepared to at least make a small wager that just about everybody in this room has something that Flextronics has played a part in the creation of, which is a rather remarkable thing. Flextronics is an enormous company, $26 billion. It's a Fortune Global 500, not surprisingly. It has a workforce of 200,000 operating in over 30 countries. Jeannine's own experience is equally remarkable. I mentioned the link with Northeastern. Her first degree in chemical engineering, awarded magna cum laude, and she clearly quite liked the Boston area, as do I, having spent time there, because she also took part in graduate programs at the Harvard Business School, then on the West Coast, the Stanford Graduate School of Business, and just to get a small European connection, at INSEAD in Lausanne. She's on the board of directors of Northeastern University Corporation and is a member of their industrial advisory board for the College of Engineering there. So, in her industrial career, Jeannine has worked for a whole variety of companies, many of which, again, I think those of us who work in the technology area will have connections with. They include Vico, Voyon Technology, Gasonics, Tencore Instruments, and the Digital Equipment Corporation. Jeannine's current role within Flextronics is as the president, I want to get the title right, which is why I'm going to check it, as the president of innovation and new ventures. She has the responsibility of the way in which new technologies come into the manufacturing process and the effects that they might have on the end customers. It's a very great responsibility, and this evening she's going to talk about the whole revolution in products that will result from the intelligence of things transforming markets and industries. Jeannine, welcome for the Barlow Lecture.
Good evening. Is this okay? It's a pleasure to be here. And I think that when we think about innovation, and I had an opportunity to take a look at the poster sessions, I continue to be inspired and excited at the kind of work and technology that's being innovated as we look at universities such as here. I think the opportunity we have is to take these ideas and synthesize them and help bring them to life in form factors and in models and solutions that we can take across industries as we think about 50 billion devices being connected. So when we think about innovation, and I think about innovation, I think about it as connecting the dots. And as we think about that, for us, that's the intelligence of things. And to get our minds around how and what that might mean to us, let's start with a short video.
There is a force so powerful that it can transform industries, disrupt the status quo, bring people together across time and space, and redefine human experience. That force is innovation. And in today's connected world, innovation is everything. We believe innovation is the engine of differentiation and the driver of success, and that value is created in the intelligence of things. We believe in the power of connected intelligence to build a brighter tomorrow. That's why we help the world's biggest brands and smallest startups across every industry bring intelligent things to life. So free your imagination, adopt the Maverick paradigm, and together, we'll change the world. Flextronics. Tomorrow starts today.
Thanks. So I think what's interesting is while some of those things may have seemed far away to us a few years ago, everything that you saw in the video is actually in production and being utilized today, and it's in a process of being transported across many different industries. And for us, as we think about what's happening in today's world, I think that we're moving from what was the information age, which is really where the internet was born, to an age of intelligence, which for us is thinking about smart and connected solutions, machines and systems that allow us to make informed decisions that will actually change the way we interact, how we live, and how we work and play. And I think the opportunity that I'd ask you to have as you think about the technologies and the innovations and the inventions that you're creating is how can we accelerate them to a point that we can actually help you think differently during the ideation stage about what is necessary to bring those things into fruition, not just from a performance standpoint or a price standpoint, but from an implementation standpoint. And for us, the connectivity of all of these different solutions is really what being intelligent is all about. And in today's market, there are a number of areas that are really transforming. So it's either smart and or connected, and that really is part of what makes intelligent things happen. And you can see this happening across a broad spectrum of industries, no longer just those industries that were compute or internet-based resources and networking. While that's still important, it connects the network of things, but many industries, such as agriculture, that might have just been in a manual, maybe going to analog world, are not only going digital, but they're getting smart and intelligent. And it allows us to think differently about how to actually deliver. And in this case, we'll talk about feeding the planet. I think from a consumer perspective, the whole concept of not only connected home and connected self, but generally connected living and connected mobility in terms of how we're going to be working together and what we're going to be doing is actually something that's not only happening at an advanced level of technologists, but actually the real benefit is how can we take that and make that be seamless and be easy and integrated so that all of our family members and people from many different regions of many different capabilities can integrate and take advantage of what is happening. And that's really part of the intelligence, to make something simple and seamless is actually one of the more complicated things to do. And I think that's really the challenge that we have in front of us, to take your inventions and your ideas and actually make them seamless and make them simple and integrated into many markets and many applications. The value, and actually Cisco, and John Chambers is noted for this, is stated that maybe up to upwards of $20 trillion of economic value will be created in the near future because of the intelligence of things, because of these smart and connected devices. The first one in healthcare is a significant opportunity, and I'm actually going to spend a little bit of time talking more about what we're seeing as a new sector, something between consumer and between medical that we call consumer health. And it's an interesting opportunity from a device and a solution space to think differently about how consumers are going to have a more active role in healthcare and in determining what happens to them. The consumer space is the one where we normally see these innovations happen first. Already over $1 trillion of opportunity. There's a significant amount of wearable technology, whether it's a Fitbit or a Jawbone or different types of capabilities that you have in terms of goggles and sensors that you'll see in eyewear that are starting to be transformed. And the consumer cycle is very short, and they have a lot of impatience. But to be able to take that and then transpose that into an industrial sector, such as energy, requires a different thinking about the implementation of the sensors and the actuators and the security systems around the software. So when you think about energy, we move from not only the experience of the intelligence of things, but to the productivity and operational execution. If you think about the opportunity, we have now over 300 million smart meters globally. We're forecasting there'll be over 1 billion smart meters by the end of the decade that allow us to think more thoughtfully and carefully as we metric energy in and out of the power grid systems. What's also exciting about that is the ability for us to introduce renewables and to be able to understand how to manage the intermittencies. And with the advent of new storage technologies, some of which I saw papers on today, I think that we're really going to finish to close the equation on what's possible as we look at operational improvements and productivity enhancements in smart grid. Transportation, and specifically automobile, is an incredibly moving industry, and for automotive that's hard to do because cycles of 7 to 9 years for product cycles in automotive are difficult. But we had a CEO of one of the top US auto companies visiting our innovation center in San Jose 2 weeks ago, and he described his company and he said, "I'm not an automotive company, I'm a mobility company. And I'm a mobility company that needs to learn how to be connected and how to be smart." So we're partnering with those types of companies, and your sensors and actuators and your solutions will help us think differently about how to manage car collisions, how to have a vehicle-to-vehicle communication, but also a vehicle-to-infrastructure. So there's also already ongoing in several cities in some countries, smaller countries around the world now, experiments with real smart city implementation in cars with sensors and capabilities that are allowing us to do things differently. And you're maybe familiar with the infotainment systems that you might already have, but now coming to you shortly will be the same kind of Wi-Fi connectivity that you're used to, and there'll be sensors in your car seats or in your seat belts that will be able to either do health diagnostic monitoring or to allow you to have different types of communication capabilities. So the entire environment that we're working in a transportation will change the way we think about, for many of us, that amount of time that's growing that we're sitting in a car. There is a lot of work, as you know, with Google cars in Silicon Valley and other things. Mercedes and BMW are already also well far along in their autonomous car concepts. They're actually forecasting that over 50% of cars in automobiles, transportation on road, will be autonomous by 2035. And a lot of that has less to do with the cars than it has to do with the smart infrastructure that's going to be needed to do that. And that's also an area where the intelligence of connecting these solutions, having the interoperability and the capability for compliance is necessary. So it changes the way you think about developing these solutions. One that I'm most excited about and some work that we're doing is really looking at food and agriculture. If we're looking at the not too distant future, having 10 billion people on this planet, our existing agriculture and food supply system will not handle it. So it's mandatory for us to think differently, and there are several leading companies across the agriculture space, who are looking at substantial yield improvement as a result of smart and connected not only tractors and solutions, but yield and crop improvements as we look to actually add digital intelligence to our agriculture processes. It may seem fairly straightforward, but agriculture is one of the least digitized industries, having been one of the largest industries in the world if you look at food, and also one that's growing and will never go away in terms of demand. So there's a huge opportunity to take the solutions that we might have thought about implementing in a consumer or in a networking space and take them to industries that really need dislocative change and disruptive change, such as agriculture. I think something to think about, and what I spend a lot of my time thinking about, is not just the cool thing that's going to hit or the gimmick, but what do you do to a system? And a system from the time of invention all the way through end of product life cycle to make innovation sustainable. Because the cycles, as you know, of time to market and the new technologies that you're creating need to come to market and they need to evolve, but we need to have a sustainability, an ability to not only go faster, but to be reliable. So we think about putting processes and systems in place, much like you might think about for manufacturing, but actually wrap those concepts in a different form factor around engineering and innovation. So it's about going fast and being thoughtful, but being predictable in how we think about having scalability and a common thread as to what we're doing with innovation. And so it's important for us to not only create something very cool that wins us a prize and allows us to actually discover new aspects of science, but how do we actually systemically incorporate this into ongoing products or marketplaces? And that reliability and repeatability and getting you access to be able at the time of invention to prototype and to build systems that are true to form early in the process is part of what we're spending time on. To facilitate how we think about the ecosystem of the intelligence of things, I'd have you think about this architecture. I spend most of my time thinking about the first two blocks in terms of cultivate and develop. And what might be interesting, and I'm excited, and yes, we are hiring and looking for probably many more engineers and technologists that are sitting in this room, is to think about how to connect the work that you're doing with labs that are in corporations, with venture capital, with the innovation centers of the world, and allow you to find a place to have a clearinghouse for technology and think about how you might productize or monetize that technology. And so we've created a collective innovation platform that we've had running now for almost 2 years, and we have over 200 technology, I won't say companies because some of them are just early concepts and entrepreneurs, but new technology instantiations that we're actually qualifying and allowing you to have pre-certification of certain building block capability that allows you to know, if I have this technology that's working in one industry, would it be applicable in another industry? What would I need to do differently in order to implement that, let's say moving from a consumer to a medical, or from a networking capability that you want to make part of that mobility solution for automotive. So we're working with a number of corporations as well as universities and consortia to think about an open and collective innovation platform, because I think we can increase the probability of creating that sustainable innovation. After you get through the sort of innovation and sourcing and cultivating, you really have the development capability and developing, robust products around a certain core set of technologies, which for us are things like smart software, human-machine interface, sensors and actuators, battery, computing capabilities. These are all the attributes of the elements of the smart and connected devices that we're going to need to make, and going very deep. And this is where the partnership with universities and corporations, I think, can be enhanced. So we think about how do we create programs and ways for you to take your technology and actually practice it in a real-world environment. And that's some of the innovation centers we set up. I think the next part of the uniqueness of the intelligence age is we're not just dealing with applications from a computing capability that started with a few hundred to a few thousand people and grew as the internet grew. We're looking at established industries such as energy or automotive or medical and we're applying smart technologies across them. And this means we have to have very good ways of systemizing their deployment to different regions, to different certifications, to different security capabilities. So there's a complexity to the intelligence of things, which is a little different than what we saw in what I'd say is the first information age. And as you think about the intelligence age, it becomes important to think about that. So taking that as a backdrop, I'd like to spend a few moments talking about digital health, and in particular, digital health moving toward what we call consumer health. So digital health has a significant amount of growth going on in the market. It'll be close to a $100 billion market opportunity by 2025. And so we're thinking about digitizing and adding real-time capability to almost any kind of medical solution, whether it's sensoring on the body or surgery in the hospital. So I think that there's a real unique opportunity to take some of the capabilities that you might have developed or thought about for consumer or other networking capabilities and apply them in digital healthcare. For quite some time, the applications have been thought about those things, and you see some of them listed here, that either a doctor would prescribe or that would be something that would be inclusive of a visit to a doctor or to a hospital or to a clinic. And that's really what digital healthcare has meant. We see a transformation happening where there's a real paradigm shift where the consumer, which is being powered by these wearable devices, powered by the access to the internet, powered by information that allows them to make informed decision, there's a desire and a thirst for a new class of devices that may or may not be sort of what we would call in the US FDA Class 2 medical regulated, but still need to have a certain level of reliability, operability, compliance, but give you the flexibility to give you more information that allow you to make better decisions about yourself and your family in conjunction with or perhaps in advance of engaging in a formal healthcare environment. And clearly the economics across the world are dictating this. As we look at the population and the aging population, you know, the business methods and the processes and the sort of systems that we have are not scalable. So we think that consumer health and taking some of these devices, which in some ways are hybridization of full medical devices for diagnosis and consumer devices where you're getting access for health and wellness, will create a new category of solutions that will require certain software and hardware solutions to be incorporated. So for us in consumer health is this intersection. And it was interesting, I presumed when I asked the question, I started to see, because we have both a consumer and a medical business, and we started to see this gray area that, well, it must be defined. We can't be the first people that are talking about this. So we went to the McKinseys and the Accentures and the Boston Consulting and whatnot, and it really hasn't been thought about yet in terms of that gray zone, and I can tell you it certainly hasn't been thought about by the FDA. When you have the FDA in the United States thinking that they need to regulate scales just because the scale has a body mass index capability on it or an algorithm that calculates body mass, you can see that our business systems as well as our device systems are off balance, literally. No pun intended. But I think that people want to use their discretionary income to have health and wellness solutions. And the form factors and the way these solutions will be deployed will be different. And so if you think about a set of platforms of capabilities, not the least of which will be, you know, the various forms of the watches that are coming to you, it was interesting to note. So we do work with both, I should say, are the top 2 or 3 of these guys who are creating these watches. And you saw that one of them decided to remove some of the capability for the biosensors. And a lot of that had to do with the characterization and the work and this whole discussion about the gray zone between medical and consumer was too much for them to sort of take on in the first generation. It was less about the actual technology. We actually have the technology. We have the sensors. We can integrate them. It's a really cool project if you get a chance to come and visit us. The thought of miniaturizing that kind of flexible electronic circuitry and sensors, it's work. I know we commented that you have a new associate professor from Delft. This is work that we also worked on with integrating work from Delft and IMEC in terms of some of the advanced sensors and actuators into these devices. but it was really about the software platform and the regulations. So we also, in the intelligence age, have this intersection at a new dimension of technology sometimes really isn't the hardest problem to solve. It's really going to be public policy or government regulations and thinking about how you're going to transpose that to a consumer. So for those entrepreneurs in the room, as you think about your business plans and business cases around devices and technology, I think it's as important, again, that sustainable innovation needs to include that filter as it relates to either regional or certain industry certifications and regulations. The technology will be ready ahead of policy. So part of our role as innovators is to help that conversation and maybe educate some of those policymakers or corporations who don't understand what's possible with technology and allow them to start thinking about this and getting it into their hands so that we can accelerate the pace of adoption. When you look across the patient ecosystem, I think there are many areas here and now today that we could be continuing to accelerate adoption at the consumer level for consumer health. Clearly the lifestyle and wellness, and we'll start to see this with the wearable devices, will be a greater extension, and you'll have the capability via your smartphone or via wearable patches and Wi-Fi connections with NFC solutions to be able to send that information to your doctor or to the website that you're using to help with self-diagnostic in advance of a medical visit. The elderly care and the aging system solutions are really interesting. We're working on a couple of solutions where you'll be able to use your iPad, and this isn't ready for, again, diagnosis officially, but think about consumer health where you have some ability with advanced image recognition capability to have a photo taken which the reader or user might not even know is being taken of them, which helps monitor whether or not you've had a stroke, or if you've had a stroke, what kind of development do you have. Sensors where you touch the tablet and it actually is telling you whether you're hydrated or not, or sending you messages as to whether you've had enough to drink or have you taken your medicine. So the ability for us to use available technology today in certain instantiations to allow independence for an aging population is, I think, a very relevant topic and one that we're going to see a lot more in terms of capabilities over the next several years. This drives new requirements. So I'd have you think about, as you're thinking about your technology, and again, sustainable innovation, making sure that you're not only quick about it, but that it's reliable, it really creates this new class of solutions where it has some of the elements that you need for a fully medical regulated device, but elements such as a conformance to HIPAA and confidentiality and security elements, which we really don't have today with a lot of the, I'll say, consumer devices. A lot of the capabilities that you have are very open network, and so there's going to need to be certain protocols that are brought into this to be able to help you think differently about having people feel comfortably about transmitting personal information about themselves over certain devices. This isn't necessarily a technology rocket science problem, but it is a systemic problem, as I said, which is part of this whole making the innovation reliable and robust. I think what is really interesting and to have you start thinking about is, do the technology solutions that you have, how can they be sort of pre-qualified and certified as building blocks that you can apply across multiple markets, whether it be consumer health or smart agriculture or energy solutions, because a lot of them at their core are actually applicable to multiple areas. And I think that's an opportunity for us to create scale in terms of adoption of new technology. And these are some of, as I mentioned, some of the key technology areas that we focus on, but also that I think you see as an underlying core of what's necessary to have these smart and connected devices. And I think many of these are things that I think there's a lot of room for opportunities for us to accelerate what's in the university labs by leveraging some of the platforms that already exist and giving you faster access to be able to productize and commercialize those. Today, I just wanted to share a few of the examples. So these are real-world examples of things that we have ongoing. They might be in clinical trials or consumers, but you can see that there's a number of areas where it really does exist today, and it's not just in a lab. It's actually, most of these are with corporations that are in the final stages of productization, so that a lot of your technology that I started to see are things you might be thinking about working on. I think you can take a look at some of these or get engaged with other companies, understand where their gaps are, and help drive some of your research and some of the work you're doing so that we can kind of intersect. I think a lot about having more accelerated innovation and sustainable innovation is really this connecting of the dots. And from the times when I was doing research and engineering, it was a very serial process. We had to do the research, and then we developed and we created the prototypes, and then we scaled it to a pilot, and then we ramped it and went through life cycles. The life cycles are shorter, but also the demand is so great. I think we have to think about basically folding a lot of these pieces on top of each other, and where possible, reuse is a great thing if you have robust solutions that we can take pieces of. But also, if you can try to fill some of the gaps that we know we have in terms of these smart patches and these wearable solutions, some of the gaps in the cybersecurity capabilities, some of the networking protocols, I think that I'd like to find ways, not just with our company, but with more companies getting tighter linked to what you think's possible so that we can sync the roadmaps up. And it may sound pretty obvious to do that, but you don't see that happening as much as I think is necessary in order for us to accelerate, again, this concept of sustainable innovation. Just a little bit of background on the work that we're doing, and I think it's important when you think about the medical spaces. It is different when you start to go into some of these spaces. Today we're talking about medical, but whether it's automotive or whether it's mill aerospace applications, you do need some capabilities, but a lot of the core capabilities for this were spawned out of the work that we had in consumer and in networking capabilities, and now you're taking them to industrial, automotive, medical applications. So we think about sort of a circle of services and capabilities, and this maps to sort of how we think about it, but it really, I think, maybe gives you a way that you should think about taking your technology and solutions sort of in the upper quadrants of this and taking it through that process and that loop. And so I think thinking about ways and what you need to be able to actually productize that and bring that to market is part of the opportunity we have. One of the examples I wanted to share is something that we're working on for diabetes. So diabetes, as you may know, is a pretty big business, unfortunately. It's a $300 billion market now. It's forecasted to reach $600 billion within the end of the decade. So unfortunately, we're going to need smart solutions for not only monitoring but managing it, because it doesn't yet seem that we're on a cure for it. So this is a solution where we've integrated a number of capabilities from both universities and companies and even new startups, such as HZO is a waterproofing capability. So you start thinking about, instead of a traditional diabetes monitoring or the pump system, that you can have a smart wearable patch that can then allow you to have information and two-way exchange to a smartphone or some other smart device, which then connects to a management infrastructure system that can give you information about dosing and give real-time feedback in order to optimize the whole process. But also, if I can miniaturize it and make it small and hide it under a soccer shirt, this is actually a prototype that we're running for some juvenile diabetes projects that we're working on. Kids on the soccer field, you want to know what's going on, and they don't want to have the big pump, and they can't be tethered. So this idea of making it simple, making it seamless, making it integrated with the flexibility to meet the needs are sort of the elements that I'd have you think about as you think about developing your solutions and your inventions and converting them into devices and solutions for a connected world. And with that, I say thank you very much.